All right, let's look at the quadratic surfaces. We're going to introduce six quadratic surfaces. First one is elliptic paraboloid, and second one is hyperbolic paraboloid, and third one is elliptic cone, and fourth one is ellipsoid, and the fifth one is a hyperboloid of one sheet, and the last one is hyperboloid of two sheets. All right, so let's try to see if we can identify these guys. All right, so here, so if you have one variable with no squares, right? So it's going to be either elliptic paraboloid or hyperbolic paraboloid, right? So then the form is that z equals x squared plus a squared over a y squared plus b squared. There's no negative sign, then it's an elliptic paraboloid. But one of them, if the one of them has a negative sign, then it's going to be called the hyperbolic paraboloid, right? All right, so those are easy to detect. And here, if you put all the terms on one side, and if you have 0, and all the terms have all the variables have a square in it, and the right hand side becomes 0, then it is called the elliptic cone, right? And if the right hand side is non-zero, then this is going to be one of these three. It's actually pretty easy to detect. All right, if there's no negative sign, it's called ellipsoid. If it's one negative sign, then this is called the hyperboloid of one sheet. If you have two negative signs, then it's called the hyperboloid of two sheets. So the number of negative sign kind of indicates the number of sheets you're going to get. Here we have the ellipsoid. So ellipsoid has no negative sign, but when you have a hyperboloid, the number of negative sign indicates the number of sheets. All right, so let's look at this following equations and see if we can identify which one. All right. All right, so let's look at this one. Z equals x squared plus y squared, right? So since z has no squares, right, squared, which means that it's going to be either elliptic paraboloid or hyperbolic paraboloid. And in this case, there's no negative sign, so it's going to be elliptic paraboloid. So this is going to be number 1. So I'll just, maybe I'll just put number 1 here. Right? How about the second equation? Right? Here, right hand side is 0, so it's going to be elliptic cone. So this is number 3. Right? Right, right hand side is 1, and all the terms are positive, so it's ellipsoid. Right? All right, here's a little tricky one, but all right, right-hand side is going to be 1. If you move these terms over to the other side, then you end up getting two negative signs, so which means that it's a hyperboloid of two sheets. So that's number 6. Right? And then how about the next one? Right? All right, this one, all right, z has no squared. Right? Then one of them has a negative sign, so it's going to be a paraboloid, but it's a hyperbolic paraboloid, so it's number 2. All right, so last one. All right, so it's not 1, but you can divide through by 4 to get 1. All right, and the number of negative signs is 1, so it's going to be a hyperboloid of one sheet. So this is number 5. All right, so it's fairly easy to identify which one of these quadratic surfaces if you follow these steps. All right, so let's look at the graph of these things by using GeoGebra. All right, I open up GeoGebra, and GeoGebra can handle simple three-dimensional graphs. So if you go to GeoGebra and click on View, then look for 3D graphics. So click on that. Right? Then you can close this 2D graphics if it's in the way, and we have that. So this is 3D graphics. Then all we have to do is type in almost exactly. So let's try to do the first one. This was the elliptic paraboloid. So here we just type in z is equal to x squared plus y squared. All right, so hit enter. You already see a picture. All right, so you see that this is it looks like a cup, right? So this is called the elliptic paraboloid, and as you can see, the reason why it's called paraboloid is that if you look at the say maybe xz trace, the trace is going to be a parabola, and if you look at the say yz trace, and it's still going to be a parabola. So it makes sense to be called the paraboloid. So, but this is an elliptic paraboloid. All right, let's get rid of that. And it's just a right click, and then you can just delete it if you want. All right, so let's look at the next one. So this is number 3. So this was what the elliptic cone. So we know what the cone is going to look like, but I'm going to just type in y squared plus z squared over 7 minus x squared equals 0. Right? Hit enter. All right. So this looks like this is a cone. Let's see. Let's see if we can zoom out. And maybe like maybe this is better. All right. So you can zoom out a bit. You can see that there's a cone on this side, and actually 2 cones kind of attached together at the origin. So this is what the elliptic cone looks like. All right, so that was the second one. All right, third one, this is the ellipsoid. So let's type it in. You have x squared over 9 plus y squared over 16 plus z squared over 9 equals 1. Right? So hit enter. All right, then let's see. I'm going to just get rid of the first one. Oh, let's see. That's not what I wanted to do. Right here. And I'm going to just delete that one. And here. All right, so this one, I can't see anything. Maybe I zoomed out too much. It was a little too small. All right, here, and you can see that it looks like the nag. So this is called ellipsoid. It's or football, right? So that was the third one, right? And here, if you look at this one, so this is so I'm gonna just get rid of that first so that we don't get confused. All right, so the next one is z squared is equal to x squared plus y squared over 49 plus 1. All right, so here, this is the, let's see, this is, all right, this is the hyperboloid of 2 sheets. And you can probably see why this is called 2 sheets. Here you can see there's a top sheet and there's a bottom sheet. So that's why it's called the hyperboloid of two sheets. All right. So that was this one. So you have 2 negative signs. If you move over to the other side, that's why you have 2 sheets. All right, let's look at the next one. This is that z doesn't have a square, so it's going to be a paraboloid. But this one has a negative sign, so it's going to be a hyperbolic paraboloid. So let's sketch that. All right, just typing it in almost exactly. So it's 8z is equal to negative y squared plus x squared. All right. So this is the hyperbolic paraboloid, and you can actually, let's see, maybe like that, and you can see that this looks like a saddle, right? So if you slice it by the plane perpendicular to the z-axis, the trace is going to have actually you can just use the XY trace. Actually, sorry, I can't use XY trace, then it's going to be straight line. But if you have a plane perpendicular to the z-axis, the trace is going to form two pieces of curve, which is this is a hyperbola. So that's why it's called the hyperbolic paraboloid, right? Which looks like a saddle, right? And the last one is this guy right here, right? So this is going to be a hyperboloid of one sheet, and you can probably see the difference between this and that. So here, so before we had the hyperboloid of two sheets, but this one has only one sheet. It looks like a drum or yo-yo or something like that here. All right, so this is called the hyperboloid of one sheet because this is just one piece. All right, we got that. All right, that's pretty much it for quadratic surfaces. That's it. I hope that this was clear.